Okay, I think we can get started. It's exactly 10 o'clock Pacific time now. So welcome everybody to this webinar. Today's topics is using Plotly, a Python library for scientific visualization. My name is Alex Razumov. I'm a training and visualization coordinator for WestGrid. And this is meant to be sort of an informal presentation, so I don't have a set of formal slides. What I have is notes that you can see in my browser here on the screen. And at the end of today's presentation, I'm going to share these lesson notes with everybody, so you don't have to write down everything that I say and show. So I'll be showing lots and lots of code examples, and you don't have to write them, to run them at the same time. You don't have to write them down on paper, because as I said, everything is going to be inside these notes that I'm going to share with you at the end of this presentation. So if you want to ask questions, there are several ways of doing this. If you're using a video client on your laptop, then what you can do is you can unmute yourself and ask a question at any time via audio. And then there is also, in the video client, there's also, if you mouse over it, there's also a toolbar at the bottom, and one of the buttons there is a chat, opening a chat window, and then you can open a chat window and ask a question right inside video. And I see there is somebody posted something. Oh, somebody is asking a question about Chapel. I'm going to answer that question. So we're not planning any Chapel programming sessions in the near future, but we'll probably do something next fall. So we currently don't have any plans. So you can ask questions via video chat, and also what you can do, you can send us an email at info@westgrid.ca, and I'll be checking that email address, well, semi-periodically as well. So in case if you're watching with the web stream. Okay. So let's get started. As I mentioned, today's topic is Plotly for scientific visualization. And there are actually quite a lot of topics that I want to cover. So we talk about, well, Plotly it's not really a multidimensional visualization tool. It's more of a two-dimensional plotting routine for creating really beautiful plots, publication and presentation quality plots for your papers or presentations. And you can also use it to create interactive two-dimensional presentations. So Plotly is not limited to 2D. You can also create three-dimensional plots with it as well. But this tool is not as powerful as a dedicated three-dimensional visualization package, such as Visit or ParaView. So you must be aware of it. But I'm going to show you a lot of examples today. So we'll go into two-dimensional plots and some simple plots, and then we'll jump into heat maps and geographical maps. And then we'll go to three-dimensional plots. And I try to give a lot of examples here for 3D simply because a lot of data sets are three-dimensional in nature. And it's interesting to see how Plotly if Plotly can work with them well or not. So as I mentioned, those of you who just joined I will share these these lesson notes at the end of this presentation, so you don't have to write down everything that I'm going to show you today. So Plotly is it's actually a library that has front-end APIs for many languages, for Python, R, MATLAB, Julia, Perl. And today we're going to look only at what you can do with Plotly from Python. So it was the library was developed actually by a Canadian company, Montreal-based company with the same name, Plotly. And the idea is to create interactive visualizations for the web. So when you run Plotly functions from Python, the end result is an HTML web page, HTML5 web page with JavaScript and JSON objects embedded into it, so that you create a static HTML page that contains not only your visualization, but also all interactions. So it can actually be quite complex. So you'll see many, many examples today. And underneath, it actually based on the D3.js JavaScript visualization library. So the plots that you generate with Plotly can be browsed online. So you can put a plot online. You can store them as completely offline, static HTML5 files on your laptop. And also, you can work with them and display them inside a Jupyter notebook. And I'm going to show you all three examples right now. So to install Plotly, what you need to do is you can install it from Python 3. So you need Python installed, obviously. And then you need to have pip Python package manager installed. And then you can simply run the command from bash or from DOS pip install Plotly. and that will install and configure Plotly for your laptop, for your environment. If you're using conda package manager, for example, for Python, then you can actually, instead of using pip, you can do conda install Plotly, and that will work as well. So there are many channels, many different ways of installing Plotly. If you want to do online visualization, then you have to sign up for a free Plotly account, and the link I provide here in the lesson notes. And optionally, of course, if you want to run Plotly from inside Jupyter, then you also have to install Jupyter Notebooks on your laptop as well. So lots of links I collected here a bunch of links for online documentation. Really, Plotly is really well documented. And again, I'm going to share these lesson notes with you at the end of this session. So what I'm going to do now, I want to mention how you can set up online plotting. So you need to, as I mentioned, you need to create a free account at plot.ly. Then you need to log in to the website, and there you need to generate your API key using the link that I have in my notes. And then that will give you your unique 40 or 30 character, I can't remember exactly, API key that you need to paste into the following code that you run from Python on your laptop. So here you paste your API code from the website, and that will write the configuration file to the following location on your system. And you need to do it only once to set up Plotly for online plotting, and then every time you do online plotting from Plotly, it will actually know the account, your account name and your account credentials, and then everything will be done automatically. So I'm going to run some demos now. Here's a simple code. Actually, let me drag this out. I will paste this code into my text window. So the setup I'm going to use today is I have a text window or a text editor on the left, and I enlarge the fonts, so hopefully you can see them. If you find that the fonts are too small for you, then what you can do, if you're using Video Client, you can actually double-click on the shared screen inside Video, and that will make it a separate window on your desktop, and then you can resize it to fill the entire screen if you want. And again, already mentioned it several times, you don't have to write down everything I'm going to show. I'm going to show lots and lots of different codes. All these codes will be inside the lesson notes that I'm going to provide a link for at the end of today's session. So here's a simple Python code, and don't pay attention to the details. We're going to study this code in a few minutes in more detail. Here, I just want to show you how you can create an online plot. So here's the Python code with Plotly, and what we have here, so we basically load the Plotly module from the Plotly library, and that will do online plotting. And then I just need to run the script. So I will run the script using the following command from Bash. Oops, sorry. It should be, I save the file as test.py, so Python test.py. And that will run the script. And it's going to be a little bit slower. Oh, interesting. Account limit reached. Your account is limited to 3. I've never seen this error before. Okay, so here's the downside of a free account, as you can see. I reached some limit, and I don't know what I don't know what that limit is. I haven't seen this error before. It just worked for me this morning. That's funny. But normally what will happen is this will create an online plot and will open it automatically inside the web page. And then at the top of the web page, you can actually see a link. So this plot will be public, and everybody in the world should be able to see your plot. If you want to create a private plot or a shared private plot that you can take a link to and then email it to somebody, but you don't want this to appear in Google search, etc., then you need a private account. And I guess there's probably some limit to the number of free plots. I don't know. I haven't seen this error message before, but don't pay attention to this. This is not important because the next option is to do an offline plot. So for offline plot, what you do, instead of importing Plotly a package from the Plotly library, you load the offline module from the Plotly library. And then we need to specify the file name into which we are going to write. Okay, so here I'm plotting my data into a file called lines.html, so a static HTML file. And let me try to run it again and see if it works. Okay, so these created a visualization and open it automatically inside my web browser. So if I do lsl on lines.html file, you can see it's a 2.2 megabyte file that was created just now. You pay attention to the timestamp. And this file contains the entire visualization. So this is an interactive visualization. You can do a bunch of things with it. So obviously you can zoom in and out. So for example, you can drag a rectangle, and you can zoom in. If you double click on your plot, it will always come back to the default view. And then there is a toolbar at the top with a bunch of buttons: zoom in and pan around and save the image and create an online plot and so on. So all the usual things. But the nice thing about this plot is that it's completely offline. So as you can see, the plotless service was complaining about me having reached the limit for the number of free plots. And in this case, actually, when I create this plot, it's created entirely offline. I don't have to be online for it. And also, it's stored as a static HTML file that you can email to somebody, or you can put it on your own website, etc. So there is a setting for auto-opening your visualization in a web browser, and the setting for this is auto open, and the default value is equal to true. So if you set it to false like this when you create the plot, then it will not open it automatically inside the web browser. So let's try it again. So here I'm creating exactly the same plot. Here's my new timestamp, just newly created plot, and as you can see, it didn't open automatically inside the web browser, simply because I said auto open is equal to false. Let me try to do this inside Jupyter Notebook, and I'm not actually entirely sure if that I'll be able to do it because of the error that you just saw, but let's try. So for some reason, I cannot do offline plots inside my Jupyter Notebook. They just never show up. But I could do online plots. But again, let's just check if online plots work now. So what I do, I open a new Python 3 Jupyter Notebook. Here it is, Python 3. And then I'm going to paste the following code into the cell. Again, so the code, the graphing routines don't matter for now. I just want to show you how to do a Jupyter Notebook plot. So I'm running this cell, and let's see if it works. Okay, and it did not work, actually because of the same problem. So I reached some limit for unlimited free account, whichever does make sense to me. So, but fortunately, we can do everything offline and not use their online service, which is really good. Okay, so here I'm killing my Jupyter Notebook. And so this gives you an idea of the plotting destination. So once again, you can plot inside the Jupyter Notebook. You can create an online plot, or you can create an offline plot. And when I was preparing for this presentation, I created at least 100 online plots, and I have not seen this error. So I have no idea what it means. But anyway, let's jump to offline plots. So let me go back to the offline code that I showed before. And I will go through it line by line, and then I will explain what the code does exactly. So here's my code. And so here in the first line, we're loading the, let's see, there is a question. You have to run Plotly offline in Init Notebook to run offline plots in Jupyter. Okay, excellent. Good to know. Thank you. Okay, so here's a simple code that creates a plus one-dimensional function, x versus y, so a function of a single independent variable. So in the first line, we're loading the offline module from the Plotly library. In the second line, we're loading the graphical objects module from the same library, and we're assigning an alias go to it. Then we're loading from NumPy the linspace function and the mathematical sign function. Then we're creating a NumPy array of floating numbers from 0 to 1 in 100 intervals, so 100 points covering the range from 0.01 to 1, and that's going to be our points for the horizontal axis. Then we create the values for the y values for these points, so also 100 points. At each point, we're computing the function sine of 1 over x. And then we create the trace object with the GoScatter function. So what this does, essentially, it creates a Python dictionary, and I'm going to show you what it looks like in a second. This creates a Python dictionary with the values of the X coordinates of all points, the Y coordinates of all 100 points, and then it sets the plotting mode. So it's going to be lines plus markers, where you will see markers for individual points and lines connecting these points. And then we optionally provide a label, so we're going to name the plot. It's going to be sine 1 over x. And then you take the data set and you're passing it to another object called data. So basically, you're passing a list of all data sets. In this case, we have just a single data set to your variable data, and then we use the variable data to actually plot the function. So let me run this code. I'm going to say Python has.py. And here we go. And actually, it usually takes a small fraction of a second, but because video recording now hijacks all my CPU cycles on both cores, it's slower than that. But usually, it's much faster. So here we have a nice plot, x versus y for plotting the sine of 1 over x function. So I already mentioned that I want to show you the what trace object looks like. So let me start the Python shell. And let me just paste these commands up to where I define the trace object. So the trace object, once again, it's a data set that it completely describes our plot. And if we print it, so I print trace1, you can see that it's actually a Python dictionary. So a dictionary in Python, for those of you not familiar, is essentially a list where instead of identifying each element in that list by its index, you're identifying it by its key value. So here we have a key value type. Type is equal to scatter. It's a scatter plot. Then x is equal to this NumPy array containing the x coordinates of the 100 points. Then the y contains the y coordinates of 100 points, and then mode lines plus markers. Okay. So this data set entirely defines our plot. We don't have to do anything else. And then we take a list of all data sets, in our case, just a single list, and we pass it to the plotting routine, optionally specifying the HTML file into which we are writing. So if you don't want to create the Python dictionary describing the data set using the scatter command, you can actually do it directly using the dictionary. So I'm going to show you what it looks like. You can do something like this, and that will create exactly the same plot. The result is exactly the same. So you're simply saying that trace, the data set, is equal to a Python dictionary where you explicitly specifying all keys and all elements. So the type is a scatter plot. You specify x, y, mode, and name, and the result is going to be exactly the same as in the previous plot. So I went back to the original version of this code where I'm using GoScatter to create a scatter plot. And let's add another data set to it. So the first one is trace1, and then I'm going to add trace2. So basically, another collection of points with x and y coordinates and a scatter plot of these points. And then when I plot the data set, I need to pass actually both data sets to the plotting routine, right? So data is now a list of 2 data sets. And then I run it. So I'll run it from the command line. And here we go. So now we have 2 plots. And these plots are specified explicitly inside our code. So once again, for those of you who joined in recently, so here some people are typing, you don't have to write down the code, because I'm going to share all codes at the end of this presentation. So I'm going to paste in the link that contains everything I say and all the codes I'm going to show you today. So let's add a third data set. Let's add a data set that I will call dots, and I will also invoke it with the GoScatter function. But here, instead of passing the NumPy arrays, I'm going to pass a simple Python list. So a list of 4 values for the x coordinates and then 4 values for the y coordinates. And then, of course, when I do actually have to do it before, I assign data. And then to data, I also now pass the dots data set. So let me run it again. And as you can see now, we have three plots. So you have a sine of 1 over x, a function plotted twice in different parts of the plot. And then you have these scatter plots with lines and markers. So lines and markers are default. We didn't specify the mode. So it shows both markers and lines in green color. So let's modify the color of our plot. Let's change the color of the line. So what I'm going to do now is I will add to the description of dots another argument that will set the color of my lines. So right here, I'm going to say line is equal to a Python dictionary containing specification of color and then the width. So I'm going to change the color to something that is, so that's RGB color. That is, as you can see, red value is high, so it's going to be reddish color, and then it's going to be a thicker line. And then that's all I have to do. So basically, I just added another keyword specifying the lines to the dots data set. Let's plot it again. And here we go. So we simply changed the line style and color by modifying the dots data set itself. So we didn't modify and change anything in the plotting routine. So what are the different plot types? You already saw the scatter plot. There are different ways of finding that out. You can obviously go to the documentation, but you can also simply print all the methods that are inside the Go module. So the way to do this, I have obviously to drop down into the Python shell, and I need to load the graphical objects module as Go. And then what I can do, I can simply say dir, so list everything inside the Go module. And there's going to be a bunch of things. So things like heatmap, histogram, contour, contours, scatter geographical plot, scatter 3D, and so on. So far we use only the scatter plot, but I'm going to show you quite a lot of, many different examples showing quite a range of different plots. So the next thing I'm going to do is a bar plot. So bar plot is right here. And I'm going to exit my Python shell. I'm going to erase everything from the text editor, and I will paste a new code, an even shorter code, that will create a bar plot showing populations in the 5 Canadian cities, so Vancouver to Halifax. And all I did was to change data set. So instead of Go scatter plot, now we have a bar plot. And also notice that so I didn't define a data set separately before assigning a list of data sets to that data. So I do it all in one line. So data is equal to a list of data sets, and then we have a single data set that is assigned with a go bar function. And then inside of it, we simply pass two lists. So one is a list of X values, so the names of the 5 Canadian cities. And then for Y, I have the populations. Okay. So let me plot this, and you will see that it's a very simple bar plot. Here we go. Okay. And again, it's interactive plot, so you can zoom in and out. You can, if you hover over any object, and the same applies to scatter plot and pretty much any type of plot inside Plotly. It will give you more information. So in this case, it shows the city name at the bottom and then population right here in the pop-up. Okay. Let's try something a little bit more complicated. So let's plot inner city population or proper city population versus the greater metro area for each city. So what I'm going to do, I'm going to erase my existing plot and paste, my existing code and paste a new code. So here I define, so again, I have the same 5 cities, and I have the plot, I have the list listing the, specifying the proper city population. So that's the inner population, and then the greater metro area, which is obviously bigger for each city. And then I'm creating 2 bar plots now. So the same notation, go bar, supplying X and Y, and then optionally the name, so inner city versus the greater area. And then I'm simply passing these 2 data sets, bar 1 and bar 2, to the plotting function. Okay. and I call it population.html. So let's plot it. And everything was written inside a population.html file, and here it opens automatically in the browser. And as you can see now, I have two bars side by side for each city, listing the inner city population and the greater area population. And obviously, the second one is always larger. So there are many different ways of plotting bars in Plotly. I'm going to show you how you can do stack plots in Plotly. So plot the same information, placing one bar on top of the other. But when you do this, you actually have to. So what I want each bar, or the total bar, stacked bar, to show the total population. So the bar at the bottom will be the inner city population, and the bar at the top will be the outer city population. So obviously, I need to subtract one from the other to get it right. And I have to do it explicitly inside my Python code. So let me show how to do this. So here we go. We're specifying the proper and metro area populations. And then I'm using Python comprehension lists to create a new list that contains the difference between the two, right? So I simply create a zip object of the two previously defined lists, and then P and M go through all the tuples of this zipped list, and I'm simply creating a new list which contains the difference for each city, contains the difference of M minus P, so metro area minus proper city population, and that will produce a new list of the outer city populations. And then I'm simply creating two graphs. So the first one is going to be the inner city population, the other one is outer city population. So exactly the same syntax as before, bar 1 and bar 2. Then I create a I create an object that contains a list of both data sets. And then what you see next is quite different. So here, we instead of passing data into the plotting routine, I next specify the layout. And I'm saying that now I want to have a stacked bar plot instead of the usual bar plot. And this is done via the layout function. So in general, everything I do from now on in Plotly will involve both specifying the data and the layout. And as you can see, both of these are passed not to the plotting routine, but to another function called figure. So the workflow will be from now on. You create a number of data sets, then you pass these data sets to an object called data. Then you create a layout. So layout describes how you want to plot your data. So things like, in this case, the bar layout, but also the title, the colors for the axis, and so on. So all these things can be specified by the layout function. And then you pass the data and layout to the figure function to create a figure, and then you pass that figure to the plotting routine, and then you specify the file name, and then you will get your two-dimensional visualization. So let's run it. Oh, actually, I need to save it first. Let's run it. And now you see I have a nice stacked plot, and so the population of Toronto, Greater Toronto area, is almost 6 million according to the data I have, and everything looks nice. So what else can we modify in the layout? Well, as I did before, when I was looking for printing out all attributes and built-in methods inside the graphical objects module, I can actually do the same for the layout function. So if I start the Python shell and simply import the module, a graphical objects module as Go, and then I can either do dir on go.layout, or I can also print help on Go layout, and that will give me a lot more information, and that will tell you, what kind of attributes and keywords you can specify when you create a new layout. So let's set the title and the background color. So just as an example, so that you know how to do this. So when I create a layout, I will also, in addition to specifying the bar mode, I will also specify the title that says population, and then the plot background. So again, RGB notation, and then let's run it again. Here we go. So now I have the title and a new background color. Any questions so far? Okay, let's continue. So next I'm going to show you heat maps. So there are actually various ways of doing this. I'm going to show you a simple way using the heat map function. And let me just erase everything from this window. And then I'm going to paste the following code. So first, I'm going to define the data, the lists. So again, I import the offline module and the graphical objects module, and then I'm specifying the months, and there are actually 13 elements here. So what I'm going to plot is the temperature at the South Pole. So record high, average high, daily mean, average low, and record low. That's all in Celsius. And I have, so each list contains not 12, but 13 elements, because I also have the last element in each list is the data for the year average, right? So I define these, how many? 5. So I define months, a month list, and then the 5 lists for the temperatures. And then I need to put all of that into a data set. So I'm going to create a variable called trace, which is a Python dictionary, and I invoke it by assign it by simply calling the heat map function inside Go, and I pass, as you can see, I pass to Z is the actual color, and Z is simply is a list of those 5 temperature lists. Then X is a list of month, and then for Y, I have a list of these labels for the 5 temperature lists. Okay, so then I need to pass it into this data set into data. So data always contains a list of my data sets, and then I simply plot that data using the plotting command. So in this case, actually don't use the explicit layout. So let me save this and run it, and you see what the heat map looks like. Here we go. As you can see, we have record low, average low, daily mean, average high, record high for 13 data points. So months from January to December, and then the year average. And on the right, we also have the label showing the, well, not the label, the legend showing the color map. And as expected, on the South Pole, well, June, July, August, so the winter months are the coldest. So let's try to do a contour map. And what I'm going to do, so I'm going to cheat here slightly. I'm going to use treat this this plot as a two-dimensional map, and I will simply replace the heat map with a contour plot. So all I have to do is when I create the heat map, I'm going to, so because the contour plot, so if I leave the year average data in my data set, the contour map actually will not be very meaningful. So I really want to use just the monthly data. So for that, I simply need to specify that instead of passing each list, I pass only the first 12 elements of that list. And I need to do that for all lists. So I'm just going to insert that string into each list, and then the same for the month. And okay, good. Then when I create the plot, I need to the dictionary. I need to specify that I'm doing a contour plot now instead of a heat map. And then, of course, when I save it, I'm going to call it a contour.html file. Okay. So let me try to run it. Okay, so here we go. We have a nice two-dimensional contour map, and it shows exactly what we want. So all data for the temperature on the South Pole. Let's try a different color map. So let's try a predefined color map that is called jet, and we do it inside the contour plot right here. When we define the data set, I simply pass another keyword. Oops. That is called color scale, and is going to be equal to jet. So we have exactly the same contour map, except that now we're displaying it in different colors. So next, I'm going to do something slightly more complicated. I'm going to show you how to do geographical scatter plots. And what I'm going to do, I'm going to use data for Canadian city populations. I have a file that is called, I'm going to provide a link to this file as well, that is called cities.csv. So it's data in the comma separated value format. So basically, I have a list of 254 Canadian cities and towns. And for each one, I have a single line description that gives the name, population, latitude, and longitude. And I need the last two simply because I'm going to plot all cities on a geographical map. Okay. So let me erase my previous code, and I will start pasting things slowly. So here is, again, I load all Plotly modules I need. Then I load the pandas pandas library for processing data frames, and also I'll be using the log10 function from the math module. So here I read my data, and I read it into a pandas data frame, and then I want to define a new column called text that is going to be used for mouse over. So when I mouse over a given marker, a given city, it will give you some information. And what it is going to plot is the city name or the town name, its population in million, and then say, so the number and followed by million, okay? Next, I need to normalize my data. So I will define a function. Actually, I'm calculating the largest, picking up the cities with the largest and the smallest population. So simply using the built-in data frame functions max and min. And then I'm defining a function called normalize, and that will simply rescale all data, all population data, to a unit interval from 0 to 1. So 0 corresponds to the smallest city, smallest town, and then 1 corresponds to the largest city. And then I create a new log size data frame column, because this is the data I'm going to use for specifying the color and the size of each marker. Then I'm going to create a data set, and for that, I'm going to use a function scatter geo. So for geographical scatter plots, and this will create a nice interactive geographical map, very similar to Google Maps, except that it will all be done inside Plotly. And then on top of this map, I can put my markers, my cities. So here I have I'm basically telling Plotly which columns of the data frame I'm going to use for which variables. So for longitude is going to be a longitude column of the data frame. For latitude is going to be a latitude column of the data frame. Then a text column for the mouse over information, then each marker. So this is important. Each marker is going to be, the size of the marker is going to be assigned according to the population. So the bigger the population of the city, so the bigger the marker is. And then the scaling is going to be size mode is area. So it's not the diameter, but the area of each marker that is going to be proportional to the population. Then the color will also reflect the population. So log size column that we created is going to be used for the color of each city. Then color scale option, I can specify the color map that I'm going to use. I'm going to use Viridis. And then show scale on the right, the legend, the color map legend, true. Then the lines, the borders of each circle. So here I can specify the width and the color of each border. And that's it. So my data set is created. And also I need to create a layout because I want to have a fairly fancy geographical map. So for the layout, what I'm going to do is I will say that, okay, the scope is North America. If you don't specify the scope, then it will simply give you by default, it will give you the world map. But option can specify, North America or Europe or something else. Then resolution 50, so that's the resolution in kilometers per millimeter of the base layer before you zoom in or out in this map. So long axis, latitude axis, so these are the ranges, basically where I truncate my map, don't show everything beyond that. Show land, and this is land color. Show rivers, and this is river color. Show lakes, this is a lake color. And then these are the borders between provinces and states. And these are the borders, so width and color between the countries. Then I simply take my data set, pass it to the figure, take my layout, pass it to the figure, and then I pass the figure to the plotting routine and specify the cities population.html file. So let me save this and let me run this code. So here I have an interactive map, and I can actually zoom in and out. And it's very laggy because video is really hijacking all cycles. So normally it takes, a small fraction of a second to build this map, but in my case it takes 5 seconds or longer. Yeah, this is all because of video. I mean, Plotly itself is really fast. And as you can see, so it's an interactive map, and we have the rivers, we have lakes, we have borders between provinces and countries. And when you mouse over a city, it will give you its coordinates, and then the text column that we specified. So the city name and its population in million. And as you can see, so here we have all 200 plus cities and towns appearing on the map. And it's fully interactive, so you can zoom in and out, and more details will appear, and it's all really very nice. Okay. So unfortunately, in Plotly, so here I'm using the function scatter geo to show a bunch of markers on a geographical map. And this works really beautifully, very easy to do. But if you want to do something slightly different, and this has not been programmed into Plotly, you won't be able to do it. So it's one of the downsides of Plotly, that it actually provides these really, really nice functions for specifying, some types of plots, but it's not all-encompassing. So, for example, if I want to do a heat map on top of a geographical plot in Plotly, that is actually very, very difficult to do because there's no such built-in functionality inside Plotly. So heat map on top of geographical maps, really difficult to do. So you have to basically hack it. There's no built-in function for that. If you try to do both a heat map and a geographical plot, the latest one will simply replace the other one. So you cannot show them at the same time. But if your two plots are compatible with each other, so for example, if you're working with two different types of geographical maps in Plotly, you can actually superimpose one on top of the other. So I'm going to show an example of a scatter geo map plotted together with a geographical choropleth map. So choropleth map is a map that shows that colors different regions, for example, different countries or different states, different provinces, in different colors according to some variable, for example, population, or I don't know, GDP or something else. So I'm going to show you a code. Actually, I won't go through the entire code because it's fairly long. I'm going to paste it here. And again, you can play with it offline after this session because I'm going to provide all codes to you. So here's the code, and here, so in addition to reading the data from cities.csv, I'm also reading the GDP data for countries. So the file is gdp.csv, and it simply is a list of 222 countries, and for each country I have the country name, GDP in billions, and then the country code. And the country code here is used to color different countries by their GDP value. So as you can see, locations, it says GDP code. So that means that these country codes will actually be used for locations to color them by the value of GDP, which is this line. So this line says that use the GDP column as the color to show GDP in different countries. So and here I'm overlaying two plots. So I'm creating a scatter geo plot and a choropleth plot, two data sets, and then I'm simply adding them into the same plot right here. So cities and countries. Let me just quickly run this and show what I mean. Okay, so here we have the same map we saw before, but now the same map of Canadian cities and towns, and it's plotted on top now of the world map, showing GDP as a choropleth map. So you can see that the GDP of China and the States is the highest, and so on, as you would expect. Okay, so any questions so far? I don't see any emails, anything in the chat window. Okay, let's now jump to three-dimensional plots. And because we don't have a lot of time, so I will go slightly quicker. But again, you can play with all codes and all plots after this session. So let me erase this frame and then paste another code into it. So first, I'm going to create a three-dimensional plot where I'm plotting two-dimensional data. So this is topographical elevation map. And the data is taken from another CSV file, Mount Bruner elevation. And actually, this example comes straight from from Plotly tutorials, along with the data set. So here what I do, I read the data again into a pandas data frame, and then I take the data, convert it into a two-dimensional NumPy array, and then I pass that two-dimensional NumPy array into the GoSurface function that creates a two-dimensional surface in a three-dimensional setting, in a three-dimensional scene. So then we have the layout to specify the title of our plot, the size, so the width and the height of the plot, and then the margin. So obviously, all of these arguments are optional. And then I create the figure, and then I pass the figure to the plotting routine and storing everything inside the elevation.html file. So let me run this, and you will see that it's going to be a three-dimensional plot. So here we go. And you can actually interact with it, so you can rotate it as you would normally expect with a 3D plot. And you can see that the color and the vertical offset actually gives you the elevation value at each point. And when you mouse over, it will give you the exact numbers of X, Y, and Z values. And then, of course, you can zoom in and out as you would normally expect with an interactive plot. Okay. So here we're plotting data, two-dimensional data inside 3D. You can also plot a two-dimensional function using exactly the same GoSurface call. So let me show you how we can plot the following two-dimensional function. So basically, it's a function inside a unit cube. So I'm going to show it here. Let's see if it works. Okay. I'm going to do something like this. So this is a two-dimensional function of x and y. So basically, sine and some arguments where x and y go from 0 to 1, and I'm going to discretize it on a 100 square grid. So in Python, there are many ways, many of how you can actually create a data set for this function. So one of the ways is going to be to use lambda functions. So you can do everything inside a single line. So I'm going to show you the code. So something like this. So plot resolution 100 by 100, and then we create a two-dimensional array using the lambda function, where x and y are simply where you see g divided by n minus 1, and I divided by n minus 1. These are effectively y and x respectively. Okay, so this creates a two-dimensional array, and then we are simply plotting this array, and here I'm specifying the width and height, and that's it. And then passing the array to a figure, and then figure to the plotting routine. Okay. So, oops, from NumPy import all. Here's a typo. So here we go. We have a two-dimensional function, and of course, this is just a quick example how, in this case, you can do everything in one line. You can use array operation to compute f. You can use something else. You can use linspace to create one-dimensional arrays for x and y, and then from those one-dimensional arrays, you can create a two-dimensional array. Again, this is just one of the many ways in Python to specify a two-dimensional function. So I'm going to skip the section on lighting control, how you can place light in a different position or have a different sort of light, different temperatures, specular spots, and so on. But it's inside my lesson notes. You can actually read it later. So quick parametric plot, and this example is also taken from the Plotly tutorials, but really nice example. So here we go. So here I'm using the GoSurface function. So first I'm creating a two-dimensional grid of phi containing values of phi, and two-dimensional grid of theta for each data point on a two-dimensional mesh. So the mesh has how many? Has 252 by 502 grid points. So for each grid point, we compute value of phi and theta, and then from these we continue. For each mesh point, we calculate the value of r, then x, y, and z, and then we're passing x, y, and z. So x, y, and z are all two-dimensional arrays containing these values for each mesh point in 2D, well, on our two-dimensional mesh. So it's going to be parametric three-dimensional plot showing the two-dimensional mesh, specifying in this fashion. And then we're passing x, y, and z, and the color scale to the surface. We specify title in the layout. Then we pass the data set and the layout to figure, and figure to the plotting function. And then let's plot it. So here we have a nice three-dimensional plot of a two-dimensional parametric surface. And as you can see, really, really fantastic plot produced by a very simple mathematical function. Okay. Let me show you an example of scatter plots in 3D. So for these, I'm using data from a website called prosperity.com. And this is just some statistical data about various countries. So let me paste the code. So here I'm using the function scatter3D. And I'm going to plot for x-axis will contain an economy for each country. On the y-axis, I have entrepreneurship opportunity. Then for z-axis, I have governance. Then the color will encode education marker for each country. And then the size of each marker is going to be a safety and security index. Okay. So as you can see now, I have a nice three-dimensional scatter plot where each sphere represents the country. So I have 222 or so, 200 countries or so. And then I have very nice five-dimensional information encoded into a single plot. So X, Y, Z are all variables, and then the size of each marker and the color of each marker encode a security and education. And obviously you can zoom in, you can spin around in 3D, and then when you mouse over any marker, it will give you the country name and its location. And obviously you can include more information here if you wish inside each pop-up. Okay. Next, I'm going to show you how you can do graphs. And again, the code is fairly complex, so probably it's not worth going through the entire code. But the data, so the code is, I'm going to create a graph using the NetworkX package in Python. Okay. And I'm going to use a custom layout called Force Atlas layout. And layout for graph visualizations simply position the nodes, right? So force layouts will either attract each nodes. Well, for example, linked nodes can be attracted to each other. Nodes that are not linked can be pushed apart, and so on. So various layouts give you different ways of positioning nodes. So I'm going to use a Force Atlas layout. And then the graph that I'm going to show you is called a Dor-Goltsov-Mendes graph. So the idea of this graph is that in each subsequent generation, every edge from the previous generation yields a new node. And then for a very high generation, it's actually going to be a fractal, very complex graph. And then every new generation graph can be made by connecting together three previous generation graphs. So it's kind of an iterative graph, as you will see. So the code for that is, I'm actually going to paste the whole thing. Then run it. So here's the code for it. And I'm also passing the generation number to the Python routine. So I'm going to plot generations, let's say 2, 3, and 4, and you'll see how they change. And so the layout function Force Atlas actually creates the positions, and then these positions are written into the arrays of, so the positions of nodes are written into the X, Y, and Z arrays. And then I also have the edges, right? And then I use the scatter3D function twice for first plotting the edges, so the links or connections between nodes, and then for plotting the nodes, and then I specify the layout and plot the whole thing. So let me show what it looks like. I'm going to first plot the second generation graph. And as you can see, it said 6 nodes and 9 edges. And this is what the graph looks like. So 6 nodes and 9 edges. Right? And again, it's fully 3D, so you can actually zoom in. You can mouse over a given node. And then what I didn't mention is that the size and the color of each node encode the degree of that node, so number of connections to a node. So the higher the degree of connection for each node, the bigger the bigger the dot is, and the lighter its color is. Okay, so let me plot the next generation, so third generation graph. 15 nodes and what was it, 27 edges. And as you can see, it looks slightly more complicated. So let me try to plot the next generation, and this will probably take a while because my laptop is just so slow with video now. And while it's plotting, I'm simply going to go to the next example. So 3D functions. Here I have, so let's say if I want to plot an isosurface, you can actually do that, and that's fairly easy. So here's one way of doing that inside Plotly. And so as you can see, the fourth generation graph had 42 nodes and 81 edges. And this is what it looks like. And again, so Plotly is not a graph visualization tool. It's just a general plotting tool, right? So you cannot take a node and drag it, or reposition nodes or reassign connections, because Plotly is not really a dedicated graphing visualization tool. It's just a general purpose visualization tool. So whatever was specified when we called Plotly routines, exactly that will be visualized. Okay, so here's the next code. Here we have a mathematical function of, now it's a three-dimensional mathematical function of x, y, and z. And it's called a deco function defined inside a cube where each coordinate runs from -1.2 to 1.2 in 30 points, so 30 cube discretization. And then to actually construct an isosurface, I'm calling, there are many ways of doing this in Python, so I'm calling the measure.matching cubes function from the SKI image library. And then it produces a bunch of vertices and triangles. So these are polygons for our two-dimensional isosurface in 3D. And then we're passing the data, the vertices, and the triangles to Plotly. And so here I'm not using the same Go graphical objects module. I'm actually using a different module called Figure Factory in Plotly, and this is because this is really the best module for plotting individual polygons in Plotly. Okay, so passing the vertices x, y, and z coordinates and triangles, and I saved it, and then let me run it. So here we have a surface, an isosurface at the value of the function 0.03 right here. And as you can see, it's a nice isosurface in 3D that is interactive. And the color map here, so the color map, this is actually quite interesting. So the color map right now doesn't encode any information. It's actually the default. So Plotly decides that this way of, a smooth transition from top to bottom will actually give you a nice visual picture. But you can actually, if you want, you can actually encode additional information in the color map. So you encode another variable if you wish on top of your isosurface. So almost the last example I'm going to show you is how to plot an actual three-dimensional data set. So I have a three-dimensional data set stored as a netcdf file. And here I'm reading, so file is called signenvelope.nc. And here I'm reading the data, printing the name of the data set and the shape of the data set. So basically the array dimensions. I think it's 100 by 100 by 100 data set. And then I'm taking data in a slice where z, so the last index is equal to 49. So it's basically this two-dimensional horizontal slice through my netcdf data set. And then I'm plotting using the usual two-dimensional heat map. So let's do that. So it's a regular two-dimensional heat map through a three-dimensional data set. Of course, what is interesting is plotting that in 3D, and you can actually do that. So here's my next example, which is actually quite long, but it shows you how you can take a three-dimensional data set and create three orthogonal slices through it. So the same signenvelope.nc netcdf data set, and here I'm creating the XY slice at a specified position, the YZ slice, and the XZ slice. And I'm plotting all three slices in a single figure. Okay? And here are the points at which I create these slices, but obviously you can move them around. You can specify any point you want. So let me run this, and you will see that the resulting picture is going to be three-dimensional. Okay? So here we go. And again, it's a static picture in the sense that here interactively you cannot move the slides. All of that is specified in the, created by the Python code. But you can, so in Plotly, I haven't mentioned that in Plotly you can actually add widgets to your plots, and I'm not covering it simply because we don't have enough time. But in principle, you can create a widget where you have a slider, and then the position of your slice in a given direction will be controlled by the widget slider. That's also possible in Plotly. Okay. So very last example is animation, because we ran out of time. So I'm just going to show you it very quickly, and here it is. So to create animation in Plotly, what you do is you need to specify a third keyword when you create a figure. So in addition to passing the list of data sets and the layout, you also specify the frames. And the frames in this case are going to be a sequence. So it's a list. Well, it's actually a list of dictionaries. And each frame contains a description of your plot. So it's color. We're going to plot markers and the position X and Y positions of our marker and the size of the dot. Right? So it's a list of frames that you pass as the third argument to the figure creation command. So let me run this, and you will see what will happen. So this will create an animation showing a moving dot along a spiral. And as you can see, it's moving in n frames. So n frames 20. It's moving in 20 frames along the spiral. And then we have a replay button, which we also programmed inside this code right here. And then when you press the replay button, it will obviously replay your visualization. So I ran out of time. That's all I wanted to show. I'm going to paste now show you the link to the lesson notes and to all the data files I used today. So here they are. I'm going to also copy and paste this into the chat window.